Alright, let's go. Number 12. The Quasicrystal. In April 1982, Dan Shechtman was doing metallurgy, not physics. He was at the National Bureau of Standards in Maryland, working through a mundane materials problem: how rapidly cooled aluminium-manganese alloys behave when you freeze them fast enough to trap them out of equilibrium. He was running electron diffraction on a sample of Al-86mm14. Routine characterization. A Thursday morning task. The crystallographic restriction theorem had been settled mathematics for over a century. A crystal is a lattice that repeats. A repeating lattice in three-dimensional space can only possess two-fold, three-fold, four-fold, or six-fold rotational symmetry. Five-fold symmetry is not rare in crystals. It is arithmetically forbidden. You cannot tile a floor with pentagons. The diffraction pattern showed 10 sharp points arranged in a perfect ring. Five-fold symmetry, with long-range order and no periodicity at all. Shechtman counted the spots and wrote in his notebook that there was no such thing. The paper appeared 2 years later. Shechtman, Blech, Gratius, and Kahn. Metallic phase with long-range orientational order and no translational symmetry. Physical Review Letters, Volume 53, 1984. Linus Pauling, twice a Nobel laureate, publicly dismissed the entire result and said the problem was not quasicrystals, but quasi-scientists. Shechtman was asked to leave his research group. Every escape route failed. Twinning, multiple crystals grown at angles faking the symmetry, was ruled out by dark field imaging. Sample contamination was ruled out by replication in a dozen labs. Pauling's icosahedral multiple twinning model survived 4 years and died against higher resolution data. Then, in 2009, Luca Bindi and Paul Steinhardt found a natural quasicrystal inside the Katerka meteorite. Nature had been making them for 4.5 billion years. The resolution, when it came, was worse than the anomaly. The pattern is legal in 6 dimensions. An icosahedral quasicrystal is the shadow of a periodic 6-dimensional lattice sliced at an irrational angle and projected down into R3. Shechtman received the Nobel Prize in Chemistry in 2011, alone, which means you can hold a projection of a 6-dimensional object in your hand, and it weighs about as much as a coin. The mathematics works perfectly. Nobody can say what the other 3 dimensions are made of. Number 11. The dimension that produced light. In 1919, Theodore Kaluza was a middle-aged, unpromoted lecturer at Nigsburg, working on a formal exercise rather than a discovery. General relativity was 4 years old. Kaluza wanted to know what Einstein's field equations looked like if you simply wrote them out in 5 dimensions instead of 4. A bookkeeping question. Pure curiosity done at a desk. The expectation was straightforward. Add a spatial dimension to a gravitational theory, and you should get a gravitational theory with extra meaningless components. Mathematical debris with no physical content. That is what happens when you add dimensions to almost any equation. You get noise. The debris was not noise. When Kaluza expanded the 5-dimensional metric, the extra components separated cleanly into precisely Maxwell's 4 equations of electromagnetism. Nobody had inserted them. Kaluza sent the result to Einstein in April 1919. Einstein held it for over 2 years before recommending publication. It appeared in 1921 in the Proceedings of the Prussian Academy of Sciences. In 1926, Oskar Klein, in Zeitschrift für Physik, explained the invisibility. The 5th dimension is curled into a circle roughly 10 to the power of minus 30 centimeters across. Then the failure parade. Klein's compactification radius predicted a charge-to-mass ratio for the electron wrong by around 20 orders of magnitude. The theory produced an unwanted 5th field, the radion, with no observed counterpart, and no mechanism to stop the extra dimension from expanding or collapsing. Einstein himself worked on 5-dimensional unification on and off until 1943 and abandoned it. Every attempt to add fermions to the picture failed to produce chiral matter, which is the kind of matter you are made of. If Kaluza was right, the light entering your eye right now is gravity, arriving from a direction you cannot point in. The equations have never stopped producing electromagnetism. Nobody knows why a wrong theory does that. from a dimension that produces light to a dimension that undoes locks. Number 10. The knot that cannot hold. Emil Artin was not investigating security or containment. In 1925 at Hamburg, he was working on a pure topology question about how two-dimensional surfaces sit inside four-dimensional space, an abstract classification problem. The kind of thing that fills a mathematics seminar on a wet afternoon. In 3 dimensions, knots are permanent. A closed loop with a trefoil tied into it cannot be untied without cutting. This is not a practical limitation. It is a theorem. Knot invariants like the Alexander polynomial prove that the knotted and unknotted loops are topologically distinct objects. Give that same loop one additional spatial dimension, and the knot falls apart. Every knot in four-dimensional space is the unknot. You do not untie it. There is nothing to untie. The mechanism is exact. A knot holds because 2 strands cannot pass through each other in 3 dimensions. In 4, you lift one strand into the 4th direction, translate it past the obstruction, and lower it back. No cutting, no stretching, no discontinuity. The result is rigorous and appears in Artin's 1925 paper in the Abhandlungen of the Hamburg Mathematical Seminar. The consolation attempts all collapse. Perhaps knots survive in higher dimensions in some other form. They do, but only for 2-dimensional spheres, and Artin's spun knots showed those behave nothing like rope. Perhaps the theorem needs a 4th dimension that is large and open. It does, which is why quantum scale compactified dimensions provide no help. Perhaps it is a mathematical curiosity with no physical analog. Nobody has proven that. Your front door, your shoelaces, the double helix supercoiled inside every cell in your body, the cage around every dangerous thing. All of it holds together because of a direction that is missing. Containment is not a property of strength. It is a property of dimension. What happens to a prison in 4 dimensions? Locks fail in 4 dimensions. So, it turns out, does your body chemistry. Number 9. The chirality flip. Immanuel Kant was not doing chemistry. In 1768, he was working on a metaphysical question about whether space is absolute or merely relational, and he chose a domestic example, your left hand and your right hand. Identical in every internal measurement. Impossible to superimpose. He called them incongruent counterparts and could not explain them. The rule is clean and it holds everywhere in 3 dimensions. A mirror image object cannot be rotated into its twin. You can flip a 2-dimensional shape by lifting it through the 3rd dimension and turning it over. There is no equivalent move for a hand. There is, in 4 dimensions. A rotation through a 4th spatial axis converts a left hand into a right hand continuously. No cut. No mirror. The object simply turns over through a direction we do not have. Now take it into biology, where handedness is not decorative. Every amino acid built into every protein in your body is left-handed. Every sugar in your DNA and RNA backbone is right-handed. This homochirality is universal across all known life, with no exceptions in the entire biosphere. Nobody knows why. Miller, Urey chemistry produces both hands in equal amounts. Circularly polarized starlight was proposed and produces excesses of a fraction of a percent. The weak nuclear force does distinguish left from right, but the energy difference between mirror molecules is around 10 to the minus 17 electron volts, far too small. Cronin and Pizzarello, in Science in 1997, found up to 9% excess of left-handed isovalent in the Murchison meteorite, which moves the mystery off Earth rather than solving it. Rotate a human being once through a 4th dimension, and every enzyme in them stops fitting its substrate. They would starve at a full table, in a body that no longer recognizes food. Life picked a hand before it picked anything else. Nobody can say who was holding the coin. If a 4th dimension can turn a body over, we should be able to watch something pass through. Number 8. The hypersphere cross-section. Edwin Abbott was a headmaster and a theologian, not a physicist. In 1884, he wrote a satire about Victorian social hierarchy, using a 2-dimensional world as the setting. The geometry was the joke, not the point. Physicists have been using it as a research tool ever since. The logic of cross-sections is not speculative, it is arithmetic. A three-dimensional sphere passing through a two-dimensional plane appears to the Flatlanders as a point that appears from nothing, widens into a growing circle, reaches maximum diameter, shrinks, and vanishes. They see no sphere. They see a circle behaving impossibly. Move it up one. A four-dimensional hypersphere crossing our space would appear as a point, swell into a full three-dimensional sphere, contract, and disappear. Total duration set entirely by its velocity through the fourth axis. This is a testable observational signature rather than a metaphor, and it turns out we log events like it constantly. Fast radio bursts last milliseconds and were unexplained for over a decade. Beatrice Villarreal's Vasco project, published in the Astronomical Journal in 2020, compared photographic plates from the 1950s Palomar Sky Survey against modern data and identified around 100 point sources present then and absent now. Each explanation covers part of the ground and no more. Plate defects account for most of the Vasco candidates. Variable stars, gravitational lensing, and instrumental artifacts absorb others. Magnetars now explain many fast radio bursts. But there is no survey anywhere designed to look for the specific signature, smooth swelling and smooth contraction with time-symmetric brightness. We have never looked for it, so we have never failed to find it. Every sky survey in history has been built by three-dimensional creatures cataloging three-dimensional objects. Our transient files are enormous. If a four-dimensional object crossed through this room last night, what in our physics would have recorded it? Number 7 asks why the most familiar force in your life is also the weakest. Number 7. The leak in gravity. In 1999, Lisa Randall and Raman Sundram were not trying to explain gravity. They were working on the hierarchy problem in particle physics, the question of why the Higgs mass stays small when quantum correction should drag it up to the Planck scale. A technical problem about numbers refusing to stay where they are put. Standard model expectation is that the four forces should have roughly comparable intrinsic strengths at high energy, with differences of a few orders of magnitude at most. Gravity does not comply. Between two protons, gravity is weaker than electromagnetism by a factor of about 10 to the power of 36. Their proposal was that gravity is not weak. Gravity is diluted. It leaks into a warped fifth dimension, and we are standing on a brane where only a fraction of it arrives. The two papers appeared in Physical Review letters in 1999. A large mass hierarchy from a small extra dimension and an alternative to compactification. The warping factor is exponential, which is why a fifth dimension only a few dozen Planck lengths across can generate a suppression of 10 to the 36. The model has been cited over 10,000 times. Then the searches. A warped extra dimension predicts Kaluza-Klein graviton resonances at the LHC, heavy copies of the graviton appearing as bumps in diphoton and dilepton spectra. Atlas and CMS have searched every accessible channel since 2010. No resonance. RS gravitons are now excluded below roughly 4 TeV for standard coupling values. The model was not killed, its parameter space was pushed into territory the collider cannot reach. Hold a fridge magnet against a paperclip. That 2-gram magnet defeats the gravitational pull of an entire planet. 6 times 10 to the 24 kilograms of it, without effort. The magnet wins every time. Either gravity is inexplicably feeble, or most of it is somewhere else. If gravity is leaking out, something should also be able to leak out. Number 6. The energy that never came back. Nima Arkani Hamed, Savas Dimopoulos, and Gia Diwali were attacking the same hierarchy problem in 1998 from the opposite direction. Rather than warping the extra dimension, they asked a blunter question. How large could an extra dimension be before existing experiments would have noticed? The assumption at the time was Planck scale, 10 to the minus 35 meters, permanently beyond reach. Everyone in the field took this as settled. Gravity, though, had only ever been tested down to about a millimeter. Below that, nobody had checked. Their answer, published in Physics Letters B in 1998, was that an extra dimension could be a full millimeter across and no experiment on Earth would have seen it. The paper carried a hard prediction. If the true Planck scale is near a TV, LHC collisions should produce gravitons that escape into the extra dimension, carrying momentum with them. Detectors would record collisions where energy and momentum simply fail to balance, the monojet signature, a single jet recoiling against nothing at all. Every avenue narrowed. The Etwash torsion balance group at the University of Washington tested Newton's inverse square law down to 52 micrometers and published in Physical Review Letters in 2020. No deviation. Atlas and CMS have run monojet searches for 15 years and set limits pushing the fundamental scale above 10 TeV for most configurations. Astrophysical bounds from supernova 1987A cooling closed the low-mass window. The millimeter version is dead. The model is not, because shrinking the dimension always saves it. If they were right at any scale, then energy is not conserved in your universe. It is conserved in a larger one you are a slice of. 15 years of null results have not falsified the idea. What would? The same model made a second prediction, and its failure was even louder. Number 5. The black holes that refused to appear. Savas Dimopoulos and Greg Landsberg were following the AD model to its logical conclusion in 2001, working out what large extra dimensions would mean for accelerator physics. This was routine phenomenology. Take a model, calculate its collider signature. Publish the numbers so experimentalists know what to look for. If the fundamental Planck scale sits near a TeV rather than 10 to the 19 GeV, then two protons colliding at LHC energies would occasionally pass within their mutual Schwarzschild radius. That is the entire criterion for black hole formation. Nothing exotic is required. Their paper Black Holes at the LHC in Physical Review Letters in 2001 calculated the rate. At design luminosity, roughly 1 microscopic black hole per second. That number leaked into the press. In 2008, Walter Wagner filed suit in federal court in Hawaii seeking to halt the collider. The LHC Safety Assessment Group, Ellis, Giudice, Mangano, Tekachev, and Wiedemann, responded in the Journal of Physics G with the decisive argument, cosmic rays have struck the moon and the earth at higher energies for billions of years, and both are still here. The collider ran. Then the searches ran. CMS and Atlas have looked for the high multiplicity spherical decay signature of an evaporating micro-black hole in every dataset since 2010. 0 candidates. Semi-classical black holes are excluded below roughly 9 to 10 TeV. Hawking evaporation was offered as an escape, but the searches target the evaporation products directly. String balls, quantum black holes, and non-thermal decay models were all proposed. All were searched. All came back empty. Both surviving answers are uncomfortable. Either large extra dimensions do not exist, or they are folded so tightly that no machine humans can build will ever touch one. The catastrophe that never happened was still data. Nobody agrees on what it measured. If extra dimensions are hiding, something might already be moving through them. Number 4. The dark matter in the wrong direction. Thomas Appelquist, Xin Chia Cheng, and Bogdan Dobrescu were not hunting dark matter in 2001. They were exploring universal extra dimensions, asking what changes if every particle, not just gravity, can move through a compactified extra dimension. A structural question about model building. Standard reasoning says momentum in a hidden dimension is unobservable. But it is not lost. Momentum quantist around a curled dimension appears to a three-dimensional observer as mass. Every particle acquires a tower of heavier copies, spaced by the inverse radius. The lightest of those copies has nowhere to decay to. It is stable, heavy, electrically neutral, and almost invisible. That is not a dark matter candidate resembling the requirement. That is the requirement, arriving unrequested. Cheng-Fing and Matchev published Kaluza-Klein dark matter in Physical Review Letters in 2002, identifying the first excited photon state as the candidate, with a relic abundance matching observation for masses between roughly 500 and 1500 GeV. Dark matter is 27% of the universe's energy content, against 5% for everything you have ever seen. The eliminations came fast. LHC searches for the accompanying colored Kaluza-Klein states now exclude compactification scales below roughly 1.4 TeV. Direct detection Xenon 1T, then LUX Zeppelin, has pushed spin-independent cross-sections down to 10 to the minus 47 square centimeters with no signal. Indirect searches by Fermi-Lat for the annihilation gamma-ray line found nothing. The viable window has narrowed to a sliver, and the sliver has not closed. If this is right, dark matter was never missing. It has been passing through your chest at 230 kilometers per second in a direction your body has no word for. We have built detectors of extraordinary sensitivity. We may have been pointing them the wrong way. Number 3 stops asking about particles and starts asking about you. Number 3, the block universe. Wim Rietdijk was working on a philosophical consequence of special relativity in 1966, not on the nature of time. His question was narrow and technical. What does the relativity of simultaneity imply about determinism? Hilary Putnam published a parallel argument in the Journal of Philosophy in 1967. From a different direction. Simultaneity in relativity is not absolute. Two observers in relative motion will slice spacetime into now at different angles. Both slices are equally valid. There is no preferred frame that settles which one is correct. This is not interpretation. It is the geometry, confirmed to extraordinary precision. Rietdijk and Putnam pushed it one step. If your now contains events that another observer's now places in the future and both are equally real, then the future is already there. Roger Penrose sharpened it into the Andromeda paradox in The Emperor's New Mind in 1989. Two people walk past each other on a street. Their relative velocity is a few kilometers per hour. Because Andromeda is 2. 5 million light-years away, their planes of simultaneity there diverge by several days. One's now contains the launch of an invasion fleet. The other's does not. Neither is wrong. The escapes were tried and none held cleanly. Howard Stein argued in 1968 that reality should be defined only along the past light cone, which saves an open future at the cost of denying that distant events have any determinate status. Presentists argue simultaneity is conventional, which requires a preferred frame nobody has found. Giedell's 1949 rotating universe solution showed that in general relativity. Closed time-like curves can exist at all, which made the problem worse rather than better. Your birth is still there. Your death is already there. You are not moving through time. The sensation of moving is the only part that is local to you. If the future exists, what exactly is the thing you call deciding? Number 2 raises the possibility that the whole structure sits on a surface. Number 2, the boundary that contains everything. Juan Maldacena was working on string theory calculations involving stacks of D-branes in 1997, a technical, unglamorous corner of the field. He was studying how the physics near a stack of branes relates to the gravitational field they produce. Two descriptions of the same object. A gravitational theory in a curved higher dimensional space and a quantum field theory with no gravity in one fewer dimension should be different theories about different things. Different degrees of freedom, different equations, different content. Maldacena found they are the same theory. Not similar. Identical, every state, every correlation. Every calculation on one side maps exactly onto the other. The paper, The Large N Limit of Superconformal Field Theories and Supergravity, appeared in late 1997 and has now been cited over 20,000 times, making it the most cited paper in high-energy theory. The correspondence has been used to compute quark-gluon plasma viscosity, matching heavy ion data at RIC to within experimental error. It has produced results in condensed matter physics. The gap is specific, and it has not closed. Maldacena's duality holds for anti-de Sitter space, which has negative curvature. Our universe has a positive cosmological constant, de Sitter space. Every attempt at a de Sitter version, from DS, CFT to holographic cosmology, remains incomplete after 25 years. And the duality tells you the two descriptions are equivalent. It has nothing whatsoever to say about which one is fundamental. The most successful mathematical result in modern theoretical physics says the interior and the surface carry identical information. Your body may be a description of something written on a boundary. The equations do not care which side you are standing on. They may not distinguish the question as meaningful. Which leaves the last item on the list, and it is not a theory. Number 1. You. Hermann Minkowski was Einstein's former mathematics teacher, and he was not proposing new physics in 1908. He was reformulating existing physics, trying to find the cleanest geometric expression of special relativity, which Einstein had published 3 years earlier in an algebraic form Minkowski found inelegant. The intuitive picture is that you are a three-dimensional object that persists through time, moving from one moment to the next, with the past gone and the future not yet made. Time is the stage. You are the actor crossing it. Minkowski's geometry does not contain a stage. Time enters as a fourth axis of a single, unified structure, and objects in that structure are four-dimensional from the start. He announced it in Cologne in September 1908, in a lecture stating that space and time separately were finished as independent concepts. What you are, in that geometry, is a world tube, a four-dimensional solid extending from the event of your birth to the event of your death, roughly 2 meters across and several decades long. What you experience as the present moment is a single three-dimensional cross-section of that shape. Nothing has dislodged it. Every attempt to restore a universal flowing present requires a preferred reference frame, and a century of increasingly precise experiments has found none. Presentism, growing block, and the moving spotlight theory all survive as philosophical positions, and none has produced a testable prediction. The physics has not needed a flowing time since 1908 and has not missed it. Every version of you that has ever existed still exists, at its own coordinate, permanent and unreachable. You are not being written. You are being read. The fourth dimension was never hiding anything. You were the thing inside it. 12 entries, and not one of them sits at the frontier of physics. Quasicrystals are in undergraduate textbooks. Maxwell's equations are 2 centuries old. Relativity has been confirmed to 11 decimal places. Every anomaly on this list lives at the center of our most tested theories, in the parts we consider settled. The universe is not confused. It is being entirely consistent, in a geometry we can calculate but cannot picture. We built a description of reality that works perfectly and describes a place we have never actually seen. The dimension is not missing. We are. If you want to see more videos like this, click the video on screen now.